Hello again, Kevin Culp, PM Head of Cloud Management Solutions here at Supermicro. Continue our podcast on monitoring and building an AI factory. In the previous video, we talked about an in-row solution for your data center. Specifically, it was an in-row CDU that is able to scale in a liquid-cooled data center, associating 10 racks essentially with an in-row solution. Today we're going to focus on the InRack CDU solution or InRack solution, which is available on a data center asset as part of our DCBBS initiatives. And we're going to talk today about sensor data collection, lifecycle management, and enforcement policy when there is a leak that is detected. So let's do it. Let's dig in and see what we can observe and discover within this particular session. So the first thing is we have an InRack CDU list, and essentially they will be all listed here. So if you had, say, 10 racks, you would see 10 InRack CDUs that are associated with each rack, provide you with a location of where that is, and that's provided in initially when you set up in pod view. So we talked about this in a previous video where we walk through the entire lifecycle management, where you take a an in-rack CDU associated with a rack through pod view. So you can look at our session on a liquid cooled data center where we go in and simulate actually a leak and show you when the enforcement policy action takes place and what action we do as far as essentially shutting down a PDU and then also or individually shutting down a server. So if you're looking for that, I would suggest you go in and look at that, which is in our video playlist that's available within the SCC YouTube channel. So I wanted to first of all just talk about I got pinged earlier this week, somebody asking me, gee, Kevin, is this a channel that's specifically for marketing or for basically sales? And quite honestly, this is intended for the DevOps administrator, you as an individual to be able to monitor and manage your data center. I guess, of course, it may be used for marketing and sales to be able to sell our product, but really it's giving you the nitty gritty of what you need to do as a DevOps administrator, giving you the tools for you to be successful in your liquid cooled data center. So I just wanted to mention to the audience here that this is intended for DevOps administrator or data center operators, that they can actually understand the significance of monitoring and management, especially for deployments in NeoCloud as we continue to build out the AI infrastructure. So enough of that. So let's dig in here and look at this InRack CDU. We have a group name here, which is not associated with a group. So it's just an individual rack that's part of our default group name. You can see here other information provided, such as the status of the control unit. In this case, CDU status. We have a check device and sensor alert, which we'll look at a little bit later. Also, the top power unit, bottom power unit, our SKU. We have different types of CDUs, 250 kilowatt for different types of use cases, 150, 100, so on and so forth. So you can look at that. And then we also can scroll across here, look at the firmware version, and then also the serial number. If you look here, we can perform firmware updates to individual CDUs. So you would click here and then actually hit the firmware update. And then it would also indicate to you the version that and caution you to be sure that this is what you want to do as far as a firmware update, because you'll overwrite the current contents. So it gives you basically a warning message there. And then you can also look at display information here where you can collapse it. In this particular use case, we don't have a lot of table data here, so it probably doesn't make sense to basically collapse it or basically reduce the amount of table column information we have here. And then you can also look at also the search criteria. Maybe you're looking for something specific for metadata you want to collect. Maybe you have uh, a number of these CDUs and you're looking for a specific event or something that is particular about this CDU that you want to basically look at. So maybe you're looking for a 250 kilowatt type of SKU and just show the 250 kilowatts within the table. In large superpod deployments and liquid deployments, we will see a number of these that are in a particular data center. So by you allowing you to be able to filter and search on these might be important to you from a lifecycle management perspective. And then we can obviously connect into the CDU website. That's really the BMC of this particular InRack CDU and take a look there. But why would you want to do that when you can look at all of this metadata here within SuperCloud Composer? All right. So the next thing I'm going to do is click on this particular location. And what it does is it brings up the front and rear view of this particular device that's sitting inside the InRack. I would want to mention here in the CDU, basically the view here, you can you have two sensor locations here, which are basically leak sensors that will ideally be strategically located in your rack. Perhaps one sensor you might want to wrap around the main supply that's coming into this particular rack. Perhaps maybe that main supply is city water, or maybe it's coming from a coolant tower, and you would wrap it around there, determining if there would be any humidity that actually gets exposed or there's a leak there, and you could be able to take enforcement action appropriately if there's humidity detected there. And the other sensor you might want to strategically locate with inside your rack to indicate if there's any humidity there in regards to a leak. And I'll get into the discussions about enforcement policy and two actions. Number one, if there is sensor data, humidity on the cold plate, and if there's sensor data inside or basically outside the server, inside the rack configuration. We'll get into those details in a little bit of in this video clip. So on the top here, we see the carousel view. We see the coolant return temperature and coolant supply temperature. And again, here you can perform updates here. So we've taken that icon or that ability for you to do it from this display to as well. And then you, of course, you can connect into the website and you can view CDU logs too as well to give you an indication of what's going on there with that particular CDU. Let's look at the navigation view here, which is going to drill down into additional information provided in our menu options here or through this control plane or this plane here of glass here that we're showing up. And let's look at sensor reading information first. The sensor reading information gives you a high-level view of lifecycle management for this particular CDU. We can scroll down here. We have them broken down into general overview, device status, states of what we're looking at from a pump perspective, other types of information we're pulling, such as liquid levels and so on and so forth. And then we've also broken it down into sensor value information. So a lot of this grouping is very easy for you to take a look at. And these are all real-time values that are actually being collected from the CDU. And we can continue down here and look at additional types of values that we're actually exposing within our monitoring platform for liquid-cooled data centers. All right, so that's a little bit on the sensor reading information. So we're going to look now into more detail more charting and graphing that we're doing based on linear charts and also various different things we're collecting. So let's scroll up here for a moment and look at each one of them in detail. So the first thing is we're looking at basically flow rate. And again, moving your mouse across here will represent data values that you're collecting in time, right? And they are time stamped. And if you use your mouse wheel on your mouse, you can actually essentially widen this particular chart to look at better detail of the linear graph, or you can actually sort of use the mouse wheel to uh, take the linear graph and pull it in. So you can pull it out and pull it in based on your mouse wheel. So this is something nifty we provided within our platform. And you can do this with any linear chart that's represented within SuperCloud Composer. We'll look at pressure. Pressure is relatively zero here, so nothing exciting there. We'll continue down here for temperature, which looks a little exciting. So we have various different linear charts here that we can pull across here. Again, going into the ambient temperature, you see we pull that data to, linear chart to the forefront here, foreground, and then all of the other charting is pulled to the back, which is in the background. And by coming across here to each one of these ones you're looking at, you can see here the actual graphing and charting is changing based on what we're doing here. All right, so we'll scroll down here and look at heat load. That's set relatively at 0. And then the humidity here is an interesting chart here that continues to cycle through here, various types of peaks and valleys that we see in this linear chart. And so forth. We'll go down and look at the power. The power is relatively stable, using 60 watts of power within this CDU. And then we also can look at pump and value and so on and so forth. So that's a little bit on the analytics and charting. On the right-hand side, we didn't talk about the date picker in previous videos, but by clicking here, you can actually do historical trending. So anything that sensor data we're providing in data center asset here for any of the solutions, whether it be in-row CDU, such as an in-row solution, the rear door exchanger, the InRack CDU, cooling tower, so on and so forth. We have a date picker that you can actually use historical trending to look as a look back window to see what kind of data or analytics that you're pulling over a period of time, right? With date values there that you can set up. All right, moving down into the next menu option, which is leak protection. So this is a value you set globally. Here, if you come down here into the admin section here for a moment, and what you're going to do is basically set the enforcement policy, right? So if it's by disabled by default, you're not going to look at any enforcement policy. So that's important to note here is that we give you the flexibility to set your own enforcement policy action. You as the administrator gets to choose what type of enforcement policy action you want to take. The default is no action. You see here it's disabled by default, right? Some of our particular neo cloud vendors and data center operators and liquid cooled don't want to set enforcement policy when a leak occurs. So we as the software vendor here, or the software solution here for you as a tier 1 solution provider at Supermicro, give you the option as the DevOps administrator to set that action appropriately for your particular use case. All right. Moving back to the coolant infrastructure InRack CDU, if we come back here, go into the navigation view here, and we're going to look at the server that are associated with this particular rack. Now, of course, these particular SKUs here are not liquid cooled SKUs. These are air cooled type of systems, right? But we're just simulating here and give you an idea of how you associate those servers to that particular rack. So when you go through PodView and you go through and you initially set up a rack, you're going to add the CDU into your rack, and then you're going to basically discover those particular appliances or servers that are out there that you're discovering that are going to be a candidate to be monitored, and then you're going to pull them in to that particular liquid cooled rack and associate them to that InRack CDU. Um, and again, these particular servers now are associated with that particular liquid cooled rack under candidates to have enforcement policy action taken against them. So before we get into the mechanics of showing you how you actually set the enforcement action, I want to walk this back for a moment and really talk about two fundamental things that are very, very important. And that has to do with, where is the leak? Is the leak, if it's detected at the cold plate, then BMC takes the action to shut down that individual server. And that action is done through the BMC to detect that humidity and appropriately set the enforcement action to shut it down. Now, we as in SuperCloud Composer, or the platform of SuperCloud Composer, basically only reports on that, right? So the enforcement action is done at the BMC, and we as in SuperCloud Composer just report on it through Redfish subscription services through Cell and Mel, right? Now, in that particular case, we're not in the tug of war to say, well, oh, BMC's taking over and SCC's taken over, and there's a tug of war there, and there's a jurisdiction of who has control, right? It clearly is delineated between BMC takes the enforcement action. Now, if a leak is detected not at the cold plate and is detected at the InRack CDU or the rack itself, then those sensors are appropriately set. In this case, they're disabled, so you would enable them coming up here to be able to enable them here by checking each one of them that you want and what type of action. We'll talk about emergency stop and what that means in a few moments, right? But if you wanted to take basically set those types of trigger events to occur within your environment to set up enforcement policy, you would basically check them. And remember, these need to be checked, but if you have not set the global option, they're not going to be available to you, right? So you have to go in and make sure that the global setting is enabled first, and then come back and set these particular trigger event settings appropriately. So, so the other thing is here is once you've set these actions here appropriately, then these particular servers are now candidates to be an action taking against them, right? So if we want to be able to do a shutdown action, and you notice here there's no action, right? Then you would basically click here and also come over and set the appropriate action, right? Here in this particular use case, right? So because the fact is that these are disabled, doesn't give you the option to basically turn so it doesn't give doesn't give you the ability to set the action, right? Because again, we're set to a disabled mode, right? So when we basically set it up here to be able to be enabled, there will be now the option for you to make a decision here. Do you want to shut down gracefully for that server? Do you want to shut down immediate action? Or do you want to put a delay in there, such as if these were liquid cooled servers that were running storage, enough time to close out your particular files, as far as your storage files, and then immediately shut it down. So that is the one use case there that you can set up and control, right? And this is done again at the server, individual server. And of course, if you were doing all of the servers and you wanted to perform an action, and so that Redfish would basically communicate to BMC saying, shut down my server gracefully or halt my particular server. But that does not mean that there is still power within the rack, right? Because remember, auxiliary power is still present because we haven't shut down the PDU. And the other use case here is coming to the PDU console and being able to shut it down based on the action there, right? So you can set up a number of type of systems to be shut down. And at that point, we have now set up a universal agent for all of those PDUs, such as Lagrange, Schneider, um, Eaton. Those PDUs now will perform that shutdown action of really shutting down auxiliary power to that particular server. And we can do that based on the whole entire rack or a particular PDU that's associated with the server, right? And how we basically do the mapping and delay the time. So it's depending on what you want to do there, whether it be immediately or there's going to be a delay and then eventually shut it down. All right. So you could see here that is in the solution to set your enforcement action appropriately within the rack if a leak was actually detected. So moving down into the CDU here, again, this is an emergency stop condition. And what this does is we're constantly monitoring specifically the flow and the temperature that's coming into the CDU. And you can think about this is if we continue to see the temperature rising very quickly or exponentially, then we will then indicate that we'll make some assumptions that the consistency between glycol and water is not there, right? And because the fact is we don't want to have no glycol present going across and flowing across the cold plate. And if it's just water, then we're going to be using boiling water, which then could be potentially catastrophic to your particular environment there, causing the GPUs to basically overheat, right? So the emergency stop condition will basically go in and shut down basically everything within your liquid cooled data center. That includes the pumps, that includes the CDU, that includes the outlets, PDU outlets, the servers, everything basically gets essentially shut down within your environment. And then you would go out and determine where the leak is, because potentially the leak may not be where our two sensors are. The leak could be maybe perhaps somewhere in your data center that you want to actually set this up for an emergency stop condition. And then we'll look at the operational modes where we can basically ability to control the pump operation based on flow that's going on there, and how you would basically set out certain values to alter the flow rate, the target flow rate and valve operation within your CDU by setting these values. All right, so that completes our session today on InRack CDU Lifecycle Management. My name is Kevin Culp, PM Head of Cloud Management Solutions here at Supermicro, signing off today. Thanks for joining today. We'll see you next time.